Mic check, 1, 2, 3. Fantastic. Hello, folks. Welcome to the 3S demo session, Spark, Scala, and Storm. So this is Rishabh Doshi, and I'll be your trainer throughout for the Spark, Scala, and Storm course. I have over 9 years of experience in IT and consulting, and basically have been dealt with the entire stack of big data in several projects. Was very fortunate enough to work with the founder of Hadoop and have dealt with Spark, Scala, Storm, the entire technology stack in almost 7 to 8 projects across different domains. Have taken 25 corporate trainings related to Spark, Scala, and Storm, and was a contributor in UC Berkeley. So basically Spark came from UC Berkeley. So basically I'm a Cloudera certified Spark professional as well as a Cloudera certified data scientist. Yeah, IBM certified in application development, a brief contributor in Tangen, MongoDB, and have dealt with several NoSQLs like HBase, Cassandra, MongoDB, and all. So this has been my contribution. I have 4 patents in analytics and machine learning space as well. Yeah, and have done my PhD. Yeah, so let's get started with the 3S. Yeah, 3S basically is Spark, Scala, and Storm. Yeah. So I hope people will be well versed, or people would be knowing about somewhat about big data, somewhat about Hadoop. And even if you don't know, don't worry at all. We'll be clearing off most of your doubts. Fine. And we'll be even doing the comparison of Hadoop versus Spark. Yeah. But first of all, let me tell you folks that basically in this particular session, we'll be introducing you what exactly big data is all about. Yeah, because that is quite essential. Yeah, how Hadoop solved the problem of big data. Yeah, how Hadoop did solve the problem of big data. So basically big data is a problem statement, and Hadoop is basically a framework to tackle big data. Correct? Then how exactly Spark came up, who were the founders of Spark, in which language it is written, and what purpose it solved which Hadoop was unable to solve. Yeah, and is Spark going to replace Hadoop completely, and how is it different from Hadoop? What are exactly the differentiating factors of Spark versus Hadoop? Is it going to replace Hadoop? Is it a full-fledged framework? We'll see that. So first, we'll see the introduction to big data. We'll see the introduction to Hadoop and how did Hadoop solve the purpose. Yeah, and then how Spark solved the purpose. Yeah, so we'll be going through all this. We'll be going through our training pedagogy, our training curriculum. Yeah, and then will tell you that how exactly our pedagogy would be throughout our 3 years course. It's a newly launched course, and basically we have amalgamated the curriculum and have customized it as much as possible so that we have our own contents, as well as we have the Cloudera inputs as well as the MapR inputs. Yeah. So we will be training you folks for Cloudera certification in Spark as well as MapR certification in Spark. Yeah. But at the moment, Spark version is also available from Databricks as well. Yeah. So most of the founders of Spark have joined a firm called Databricks. Yeah. And I had been training Spark from Databricks throughout the European continent. I'm currently based in London. So I had been training folks in the European continent via Databricks. Yeah. Most of the founders of Spark from UC Berkeley have joined Databricks at the moment. Yeah. So we'll be training you folks that how to crack the certification. Okay. And we'll be doing 3 multiple projects of Spark, Storm and Scala. Yeah. And there will be 3 projects that we'll be doing. One on machine learning, another on graphics, and the third is on a warehousing and a streaming project. Yeah. So it's ultimate joy, guys, and very fascinating and exciting because this is freshly launched course. Yeah. So let's get started. Let's get going. And the demand, as far as the market is concerned, guys, the demand for Spark, Scala, and Storm, especially Spark and Scala, is at the peak. Yeah. And people knowing Spark are very less. Yeah. Because Spark is written in a language called Scala. Yeah. Most of its code is written in Scala. I would say around 70–80%. Some of it is written in Python and Java as well. Yeah. And Scala developers itself are very less. So we'll be training you folks on Scala. Then we'll be moving towards Spark, that how we utilize it into Spark. And then we'll be going towards Storm. Yeah. Storm is altogether a different framework, a real-time streaming framework. Yeah. So it's a progressive journey that we'll be doing it. First, we'll be laying down the foundation, and then we'll be moving towards Spark, and then we'll be going towards Storm. So as far as you guys are at the right moment, at the right place, at the right time, because the demand for Spark, it's growing and growing, might be replacing the traditional MapReduce framework of Hadoop. Yeah. So just let me give you quickly the introduction of big data, as some of you would be already knowing what exactly big data is. Yeah, but still, let me quickly give you the introduction to big data, what Hadoop was trying to solve, and how then Spark came up and conquered everything. Yeah. So big data. And guys, I'll be unmuting you every 20 minutes so that you can ask your questions and you can clarify your doubts. Okay, so don't worry about that. I'll be asking you the questions every 20–25 minutes, and we'll make it as much interactive as possible. Yeah. So, big data. Now, folks, throughout my experience in big data, people always talk about 3 V's, 3 V's, or 4 V's, or 5 V's, but actually, the most important V is veracity. Veracity? What do you mean by veracity? Veracity means you are not clear where the data is coming from. Yeah? Data sources are unclear. You don't know where the data is coming from. Yeah. Data sources are unclear. It might be a Twitter data, LinkedIn data, Facebook data, it might be a database data, DB2 data, Oracle, MySQL, blah, blah, blah. Yeah. It's an amalgamation of several data types. Yeah. Now, this blended data, how to merge, create a data lake, and read insights out of it. Yeah. So this is just one part of it. Yeah. And this is one of the most important. And because of all these data sources, volume is piling up like anything. Yeah. Volume is piling up like anything. We are no more into the age of GBs, moving towards terabytes, petabytes, exabytes, zettabytes. Yeah. Continuously moving towards this particular area. Yeah. We all would have heard about Moore's law, right? What is Moore's law? As year progresses, the number of transistors in a chip will increase exponentially, and the hardware will be, or the chip will be, more and more compact. So storage capacity will increase, but chip will become, or the hardware will become, more and more compact, more and more small. Yeah. So that you can stuff as much data as possible. But these days, even data feeder mechanisms, software platforms has also increased a lot. Yeah. That data is piling up like anything. Several social media platforms, mergers and acquisitions, banking transactions, lots of logs data is getting created. Yeah. So to handle this humongous amount of data is an ask. Yeah. And it's not just storage. We also want to reap insights out of that data very fast, very quick. Yeah. I want real-time analytics. Fine. And because of this reason, Hadoop was capable to solve everything. Because mainly of this V, velocity, Spark has conquered the market. I am not saying it will replace Hadoop, because still Spark is using others' storage. Yeah, it's using the storage of Hadoop, or might be S3, or might be any of the NoSQLs or database. But Spark is a general purpose computation engine, yeah, or a general purpose application framework, which is doing the computations approx 10 to 100 times faster than the traditional MapReduce framework. Because it's working on the concept of in-memory computation with a distributed setup. Yeah, combination of them. Yeah, there is a concept called RDD. We'll be seeing that later. What is RDD? It's resilient distributed data sets on which it is working. And because of this, and its lazy learning or lazy evaluation techniques, Spark has been a lot more popular. Yeah, especially it's written in a language called Scala, which is highly scalable language, and Scala basically has the advantages of object-oriented as well as functional programming. Yeah, but yes, as I mentioned, because of this particular velocity, Spark is having an upper edge. Yeah, and Spark basically it's a unified framework. Spark is a unified framework. It's a unified stack. So what do you mean by unified stack? Unified stack means Spark basically is having a machine learning library, it has a graph processing engine, and It has a warehousing engine. Yeah. Fine. So volume, velocity means high frequency data like in stocks. Real-time computation or real-time analytics. Yeah, it provides a parallel computation framework. Hadoop as well as Spark, both. But Hadoop's batch mode processing is a bit slower. And variety. Yeah, structured and unstructured data sets. You don't know where the data is going to come from. Yeah. Unstructured means your Twitter feed, your email, these are all unstructured data sets. Correct? Got it? Yeah. So this is all about big data. Now, how Hadoop solved the purpose? Hadoop, guys, had or still has two core components. Hadoop has its storage Hadoop has its own storage, and Hadoop has its own computation framework. Hadoop has its own computation framework. So Hadoop's storage, we used to call it as HDFS. HDFS stands for Hadoop Distributed File System. Hadoop Distributed File System. And computation framework for Hadoop is MapReduce framework. So basically, Spark is not replacing this one because Spark does not have its own storage engine. Spark does not have its own storage. It utilizes others' storage, fine, like HDFS or NoSQLs or so. So there is nothing related to this one, fine. And we also will be using or deploying our Spark on HDFS, fine. And we'll be doing all the computations. It can be deployed anywhere. It can be deployed on Apache Mesos, Yarn, S3, etc., etc. But Spark is all about this one. The computation is over here. The comparison is over here. With the computation framework, I do have the comparison. So it's a general purpose computation engine and has in-memory computation. Fine. So let me give you the introduction of Spark. So what is Spark? As I mentioned, it's a distributed data analytics engine, generalizing MapReduce, and Spark is written in Scala. It's also called as a unified stack. Spark is written in Scala. Scala, it's a highly scalable language. So Scala basically has the advantages of object-oriented programming plus functional programming. Object-oriented programming plus functional programming. There are other languages like Haskell, which were into functional programming. Object-oriented programming, you all would be knowing. Java is an object-oriented programming language. Yeah, but Scala clubs the advantages of both of them. So what do you mean by functional programming? Functional programming means functions are treated as first-class variables. That means, let's say if I'm writing an add function. Now inside the add function, if I'm writing any variables over here, in Java it was not possible to write these variables as function itself. Let's say inside add, if I want to give a variable, yeah, let's say x1, I want to give a variable x2. Fine? Yes, obviously x1 is a variable, x2 is a variable. It's possible in Java. But over here itself, if we want to give functions, function add, if I give subtract, division, this is not possible in Java, which is possible in Spark. To give function inside a function, function as an argument inside a function. Yeah, so this is what Spark is about, because it's written in Scala. It's about Scala, Scala's advantages. Yeah, so basically it's a core engine with streaming SQLs, machine learning and graph processing modules. It's a unified stack, guys. It's not like Hadoop that for doing a warehousing you need to download something separately. There is a separate project for it, like Hive. Yeah, fine. For doing machine learning, you need to have Mahout in place. You need to download that. It's a separate project. Blah blah blah. Yeah. For doing graph processing, there is Giraffe. Fine. For doing streaming, you have Flume, Kafka, and all. So basically, if you download Spark or if you have Spark engine, all these things are pre-built. You don't have to go anywhere else to do anything else. Let's say for machine learning, that's it. You can do it with Spark. For streaming, you can do it with Spark. Graph processing, you can do it with Spark. All these modules are packaged together and it's available as a unified stack. It's available as a unified stack in Spark. That's why it's damn popular. It's very, very popular because n number of iterations or stuff you want to do, you just need to download Spark. That's it. Plug and play, start utilizing it. That's it. That's why it's very, very popular. Yeah, and even comparing Hive with Spark's warehousing, that is Shark SQL. Shark SQL's performance is pretty much higher. Yeah, same goes with the machine learning library of Spark with Mahout. Machine learning of Spark is pretty much higher. Yeah, so because of all these things, yeah, Spark is gaining an edge. Yeah, correct. So this is what your Spark is all about, and this is how we do the comparison guys. Yeah, fine. So as such, if you want to compare Spark, compare it with Hadoop's MapReduce with Spark. Yeah, please compare Hadoop's MapReduce with Spark. Fine. It's a computation versus a computation. It's a computation battle as such. Yeah, it's a computation battle as such. Fine. Yarn versus Mesos. Yeah, so Yarn basically was invented by Yahoo, commercialized by Hortonworks a lot. Yeah, it's basically yet another resource negotiator. That means in prior years, in the initial releases of Hadoop, only MapReduce used to run as a native framework. But now you can even use other computation frameworks like Spark, Storm, etc., on top of HDFS. Yeah. So same goes with Mesos. You can deploy anything on it and compute the data. Yeah, Hadoop HDFS, which is a storage engine. Yeah, it's basically a storage framework. Compare it with Tachyon. Again, it's a storage platform. Yeah, so this is how one should do the comparison. Sometimes people compare completely Hadoop with Spark. It's Hadoop's MapReduce with Spark, not complete Hadoop with Spark, because Hadoop has two things. It's storage and computation. So compare, Spark is all about computation. Spark does not have its own storage. Okay, so Spark is deployed on another storage, let's say HDFS locally on HBase, or let's say Cassandra or MongoDB. Yeah, got it? But its computation framework changes where it's making sense. And this is how individual Hadoop components fine, are compared with Spark. As I mentioned, Mahout, right? It's a machine learning library. Hive, right? And comparing this with Spark, Spark is very, very fast. Processing time is very less. Yeah, so that's why it's gaining the edge over Hadoop and its core components and its incubating projects. Fun. So this is how the comparison should be done, and it should be crystal clear in your head. Yeah, so basically this is the core Spark. These are the things revolving around. Fine. You can do analytics. Yeah. You can use Scala framework, which is the native language of Spark. You can use even Python. You can do the coding in Python as well. We can do it in Java as well. You can do it in R as well. R Spark is also available. Yeah. And these are the storage engines which it is using it. Yeah. Or this one. Or its own local file system. Yeah. So these are the distributions. Enterprise vendors, you have Cloudera, Hortonworks, MapR, Databricks. Yeah. They all are providing, or even DataStax. These days even DataStax is also there, which is the major enterprise vendor for Cassandra. Yeah. So these are the distribution vendors of Spark, from where Spark is available. But as such, we'll be using the Apache one, which is a vanilla flavor. Right? And we'll be seeing even other distributions as well. What are the comparisons between these distributions? Got it? Fine. So these are some of the most important diagrams, guys, comparing Spark with Hadoop and all. Okay. So as I mentioned, Spark does not have its own storage. It has its own computation framework. So Spark as a main program, fine. Like in Hadoop also you have a driver. Yeah, you have a job tracker and several task trackers. So job tracker is basically the master of MapReduce, and task tracker is basically the slave of MapReduce. Hadoop basically works on master-slave architecture. So folks who are not well versed with Hadoop, don't worry. Yeah, we'll be clearing off the basics. Yeah. Okay. So we'll clear off the basics of Hadoop. Don't worry about that. Okay. And whatever is required to study about HDFS and all, HDFS shell commands and all, we'll be discussing that. So don't worry. Okay. So prerequisites, don't worry at all. We'll be covering it entirely. So job tracker is a master of MapReduce. Task tracker is the slave of MapReduce. Hadoop basically works on a master-slave model. Yeah. So job tracker is a delegator, and task tracker is the one which performs the actual logical operation. Yeah. Job tracker is the one which is the delegator. It delegates the tasks. Yeah. Job tracker is the one which delegates the task. So same over here, you have Spark driver and you have Spark workers. It's like task trackers. Yeah, because Spark also believes in data localization. data localization. That is running your source code where the data is, running your logic where the data is. Got it? Fine. Super. Now, as far as Spark is concerned, guys, as far as Spark is concerned, the main important topics that you should know about Spark, yeah, is RDD, yeah. RDD stands for resilient distributed datasets. Resilient distributed datasets. Yeah. And basically it's fault tolerant. Why it is fault tolerant and why it is resilient? Yeah. Obviously HDF is also fault tolerant because of the replica management mechanism and all. Yeah, because you have the replicas of the data in HDFS. But this is the computation framework. Yeah, and it's resilient. How it is resilient? Because it works on lineage. Yeah. So what is RDD as such case? Yeah, what exactly is RDD? Yeah, what exactly is resilient distributed data set? Let me first tell you that. So let's say this is the entire block. Okay, and resilient distributed data sets is immutable, can't change. Fine. So it's immutable collection of objects. This is, let's say, object 1, object 2, object 3, object 4. So basically this entire block itself, it's partitioned and it's distributed across clusters. Fine. So it's partitioned and distributed. So this is step 1, immutable collection of objects. Step 2, partitioned and distributed. Step 3, it's stored in the memory. Fine. It's stored in memory. The data is being cached. Yeah, this is one of the biggest advantage. The data is being cached and then it is being computed. Yeah, and then partitions recomputed on failure. Because of this reason, it's resilient. That means basically you would have heard of a concept called DAG. What is DAG? DAG stands for directed acyclic graph. Yeah, directed acyclic graph. That means, let's say, I'm just showing an example. Yeah, step 1, step 2, fine. Step 3, 4, 5, 6. Let's say something is gone wrong over here. Okay, fine. Then what I'll do, I won't recompute the entire thing. Yeah, I won't recompute the entire thing. I'll just go a step before that. Yeah, I'll store the computation still here. I'll go a step before that, and then I'll do the recomputation, and then I will do the recomputation. Yeah, that's what we call it as lineage. Yeah, it's basically lazy evaluation. We call it as lazy evaluation. Yeah, lazy evaluation. Yeah, so as I was talking, right, about Spark, some of the important concepts of Spark is RDD, yeah, transformations, yeah, transformations, and then it's actions. Yeah, so RDD is a resilient distributed data set, fine, which we just saw the brief of it. Yeah, don't worry, we'll be covering it in entire stretch. Transformation, it's kind of, let's say there are a bunch of lines. Yeah, so transformation is nothing but, let's say I'm reading a line or reading a file. Yeah, let's say I'm reading a file. Fine, I am filtering the lines. So let's say in some lines Spark is present, so I'm filtering it and filtering the lines. This is just one sort of transformation. Yeah, and what are actions? Now actions are count. Let's say I'm counting the number of lines, I'm counting the number of words, yeah, average, etc., etc. All sorts of computations, yeah, are actions. Now until and unless, yeah, an action is triggered, yeah, transformations and everything will take place, fine, but it's not computed. Yeah, action will not take place until it is triggered, fine. So let's say there is a chain of process, opening a file, filtering it, blah blah blah, all these things will be cached, but it's not computed. Yeah, counting, averaging, nothing would be done until and unless it's being triggered, and as it's being triggered, it's already being cached, and then it's being computed, so you get the final outcome. That's why I told you it's lazy evaluation, it's lineage, it's all about lineage. Yeah, so this is your RDD, guys. Let's say there are multiple nodes running. Node A, RDD1, partition 1 is running. Yeah, so RDD is nothing but collection of records. Okay, RDD2, partition 1. Yeah, so you see how it's being distributed and it's computed. The computation is happening. Yeah, now how does Spark execute a job? You have a master node. Yeah, obviously it has, you know, a delegator and a task performer. So master is the one which delegates the task to the slaves. So as I told, it's in-memory computation, so data caching is done in the RAM or disk. Fine, and until unless the action is triggered, evaluation does not take place. So it's being cached already, but then when the action is triggered, then you get the result automatically. Yeah, you get the result automatically. So this is how Spark executes the job. Fine. So you yourself decide which you would like and why you would like. Yeah. Obviously, your choice will be second one. This would be your choice. Fine. Because over here, every time iterations is happening. Loading a file, going to the disk. Again doing computation, going to the disk. Instead, just cache everything. Do all the transformations. Actions will apply it later. Correct? Actions will be applying it later. Fine. So, because of this, you see, these are the performance scenarios. If you compare Hadoop's stack Yeah, just computation stack. I'm not talking about HDFS again. Again, I'll repeat. Spark is not going to replace Hadoop because Hadoop has its own storage, that is HDFS. Spark might replace only the computation part of Hadoop, that is MapReduce framework or other technology stacks of Hadoop like computation stacks of Hadoop like Hive, let's say Mahout. Yeah, all these things it might replace because performance wise it's pretty fast. It's very, very, very fast. Yeah, you see the response time over here. Got it? Yeah. So comparing each stack with Hadoop stack. Yeah, and this is a Spark versus Storm comparison. Anyways, we'll be seeing that. Storm is basically written in a language called Clojure. Yeah, Spark is written in Scala. And Storm is basically for real-time streaming analytics. Yeah. So this comes with the Java API. You can do the coding in Java. This can be programmed in Scala, Java, as well as Python. You can do it even in Python. Yeah. Okay. So these are some of the comparisons. So anyways, we'll be seeing it in detail, the comparisons of each one of them. Yeah. And because of this, Spark in memory is quite favored and people like it a lot. Yeah, as it's in memory computation. Fine. And its graph processing engine, it's also quite humongous, has a pretty nice library available. Yeah, and almost you can compare Spark's graphical library with Neo4j. Neo4j is world's leading graph NoSQL database. Yeah, you can compare this with Neo4j. Almost it's trying to match the libraries of Neo4j. Right? Okay, so we'll be seeing the machine learning part, graph processing part, as well as the Spark data warehousing part, which is the entire stack of Spark. We'll be seeing it. Yeah, and we'll be analyzing it on different projects. Yeah, we'll be doing real-time case studies as well. Fine. So these are the advantages of Spark, folks. Speed runs a program up to 100 times faster than Hadoop. Yeah, writes applications quickly in Java, and as it's a unified stack, it's pretty simple. Got it? So let me take you through the syllabus that we'll be covering, guys. Yeah. So we are kicking off the batch, guys. We are kicking off the batch Monday onwards. Monday same time. Yeah. 8 p.m. EST. 8 p.m. EST. We are starting off the batch. Fine. We are starting off the batch. So this is our course curriculum, folks. So those who have attended my Hadoop batch, they would be already knowing the training pedagogy. Said that after every module, we conduct a test. Yeah, after every module, after every 25% completion of basically the course contents, we conduct a test. So all in all, we'll be conducting 4 tests, 4 plus 1. There will be in total 5 tests that we'll be conducting in order to assess how you guys are performing. Yeah. So this is the entire Spark, Scala, and Storm stack that we'll be going through. Yeah. And our syllabus almost matches like Cloudera and Mapper. Yeah. We have the same sort of training pedagogy as well, because I myself do take trainings for Mapper as well as Cloudera. Yeah, but right now I'm quite a lot affiliated with Databricks. Okay, so let me come back to your questions, guys. Those who are having any questions, if you have any questions related to timelines and anything, furthermore related to logistics, you can connect with the Techie training team. Yeah, so for enrollment, You can connect with them if you have any further queries. And please check out your inboxes, guys. You post-session, post-session, please check out your inboxes. You'll be getting mails from the support staff. You all will be getting the VM access, the virtual machine access, because we'll be kicking off the practicals from session 2 onwards. Correct? So those who are having any questions related to training, pedagogy, any technical questions, you can click on the yellow colored hand symbol. Any question, please click on the yellow colored hand symbol so that I can unmute you and you can ask your questions. I'll unmute you and you can ask your questions. And if you are traveling somewhere in the middle and can't talk, you can type in your question in the question box. Please click on the yellow colored hand symbol, folks. So let me come to Venkatesh Varao. Yes, Venkatesh?
Yeah, how will you guide us in the job assistant? Do you have any job assistant programs? Resume preparation?
Exactly. Yes, we do prepare you for resumes, as well as we have our consultants in whichever geography you are, especially in the US, Asia Pacific, and even we have started off in Middle East. So we have our consultants over there, and we'll be assisting you. And daily, even updates also will be giving across different geographies where the stuff is going, what kind of job openings and new opportunities are coming up. But as far as SPARK-SCALA is concerned, definitely it's very much high in demand. You can take our help, but definitely you can sort out the purpose on your own as well, because it's very much high in demand and people are very less. People are very, very less. But yes, our training team, our consultants would help you out. More of the stuff you can get it from the techie training team, about how they'll help you out in the job and the resume preparation stuff. But definitely we'll be preparing your resumes as well. And post training also we do one-to-one Skype calls as well. Let's say if you're going for an interview day after tomorrow, then before 2 days we conduct an interview and we prepare you in such a way that how exactly to face the interview, what kind of questions you can expect and all that. So we do conduct a mock-up Skype call as well. So don't worry about that. Let me come to Vishnu Bhagat. Yes, Vishnu?
Yeah, thanks, Rishabh. I wanted to know, like, for SPARK-SCALA and this Storm, what is the machine configuration that I need to have?
So basically, yes, we'll be doing it on VM. There is a VM image that support staff will be giving you, and it's a lifetime access. At least you need to have a 3 GB RAM, and hard disk wise, if it's at least 10, 20 GB, if it's available, it will be good. But hard disk wise, I'm fine enough. But at least RAM, if you have 3 GB RAM, it will be really good. It will be fast enough. As such, 2 GB will do, but sometimes it slows down a lot. But minimum 3 GB RAM is required. And as such, OS wise and all, it's quite flexible. You can install it anywhere on Mac as well as Windows as well as anything. So it's fine.
I have only restriction on the hard disk space. Can I use external hard disk? And
definitely. You can use external hard disk for sure. Definitely.
Okay. And what about the certifications?
So as far as certification, so as far as certification is concerned, we will be providing from our institute a training certificate. That's for sure. But apart from that, Cloudera, Mapper, and all are all external ones. So Cloudera Spark certification, then Hortonworks Spark certification, Mapper Spark certification. We'll be preparing you for that. Most of our folks have cleared it out. So within one go. That's not a problem. We'll be providing you with lots of dumps as well. So as far as certification is concerned, don't worry. But our main target is to make you project ready. The thing is, in some of the organizations, you will be really surprised. Even projects of Sparks are not started, but they have started preparing the bench strength for it because they know this is going to be the future. Some of, I would say, 20-30%, they have already started working on to Spark, but I would say 70 to 80%, they are just recruiting Spark professionals to start preparing their bench, and because they know that their existing Hadoop frameworks are also or will be converted into Spark. Yeah, so there's lots of work that's going to come. The demand would be at peak high, at least for the next 2 to 3 years, definitely, no doubt about that. Yeah, because the main reason is Hadoop was written in Java. This thing is written in Scala. Scala developers itself are very less. Yeah, Spark in itself is a niche computation framework, but Scala developers are also very less. You can assume what the demand would be. Yeah, Scala developers in compared to Java. Yeah. Java for IT professionals has become the next mother tongue. Yeah. Okay, let me come to Amit Shinde. Yes, Amit?
Hey, Rishabh. So I already gone with the Hadoop classes with you. As such, there was no prerequisite to learn Hadoop. So what is the prerequisite of learning, Storm, Scala, and
Excellent question, Amit. So basically, in Hadoop, as such, the prerequisite, where core Java, some of the basic Unix commands and all, and that we were covering it very quickly because we didn't have that much time to go in depth of Java and all. But over here, the prerequisite itself is Scala, and Scala we are giving enough time in this particular course. We'll be starting off with Scala, to code in Scala, to do the stuff in Scala, because people are not well versed with Scala and people doesn't know Scala language at all. So we'll be learning Scala language first, we'll be going to Spark after that, and then we'll be going to Storm after that. So the prerequisite itself we'll be covering as part of our syllabus only, and we'll be going in depth this time. So prerequisites, then we'll be starting off with Spark, and then we'll be going with Storm, because most of the organizations in future also they'll be using its native language. Native language of Spark is Scala. So yes, we'll be starting off with Scala. So don't worry about the prerequisites. Prerequisites itself we'll be starting off with. Yeah?
okay, thank you.
Perfect, Amit. Let me come to Dai D. Yes, Dai? Yes, Dai. Speak up.
Hi, Rishabh. First question is, how do you compare the Spark with SAP product portfolio? Do we have any competitor in SAP side?
Basically, the reason is, why Hadoop? Hadoop was very popular. There's no doubt about that, and it's still popular. Yeah. Its computation part was a bit challenged at times. The people who have already, or the banking industry has already implemented SAP. Computation-wise, it was lagging a lot. Yeah. Because of the in-memory part, which SAP was already having, and its pre-built libraries and all that. Yeah. Now, as Spark has come, banking industries like I would literally name the banks like Barclays, HSBC, as well as Santander. Fine. They are looking to the Spark stack quite anxiously and eagerly. Yeah. They are still going with their own SAP stack, but HSBC has already rolled the program, yeah, to eventually replace it, the Hadoop stack which they already had, or the SAP stack which they already had, replace it in the terms of data splitting, that what data was going to SAP, it should even go to Spark as well. Fine. Because computation wise now also, even Spark is a lot more cheaper than the licensing of SAP, but computation wise also, it's giving quite a tough competition to SAP, which Hadoop was unable to give. Yeah, because of Spark's in-memory feature. Yeah, so that's why I would say it's having an edge. Spark is having an edge over SAP. Yeah, and any open source definitely has an edge, and Spark has an open source enterprise vendors also available like Cloudera, as well as MapR, Databricks, and as well. Yeah, before, I would say 6 months or 1 year back, enterprise vendors of Spark were not available. For Hadoop, yes. For Spark, there were only, I think, MapR only. Yeah. But now even Databricks is there. Databricks is a very nice enterprise vendors, and they have a kick-ass Spark technology stack. Yeah. So yes, people are now trusting the open source, the Spark stack, and yeah, it's a huge competition. You can yourself see, guys, you know, the job openings as well as for Spark, be it in Glassdoor, LinkedIn, Indeed, yeah, tremendous. Yeah, and even the billing rates, let's say people are looking for contractual roles and states, yeah, billing rates also you can see. Compare it with Hadoop, compare it with SAP, and compare it with Spark. Yeah, yourself decide, and you can check it out. Let me come to Kamakshi. Yes, Kamakshi.
Yes. Rishabh, can you hear me?
Yes.
Yes, I had a question. The reason why I'm asking this is because my company is moving to both Spark, and Scala, Storm and Scala, and I'm one of the lead engineers. And my question was, this is just a 30-hour session. How intense is this training going to be? Because
the thing is, Kamakshi, this is, I have been doing most of the times corporate trainings into Spark, Scala, and Storm. The online, I'm bringing it for the first time. Yeah, this is for the first time I'm bringing it online. So we have kept it 30 hours. It's on an average. I'm damn sure we'll be going much beyond that. So
yes. Okay.
30 hours is just the least number of figures we wanted to give, because we don't want to experiment as such, and we don't want to quote it much higher, like 40, 45, 50 hours.
Okay.
Because, yeah, so I have been doing corporate trainings. Let's say it's an 8 hours corporate training, 5 days. So 5 days, it's basically 40 hours you take it out.
Okay.
But how you match a corporate with an online one? Yeah, we are doing it for the first time, so I don't want to quote it much higher. But yes, we'll go with 30 hours. But I assure you that at least it would be 30 hours. It would be obviously going much more than that.
Okay, because I've been looking at the literature and it's quite voluminous, and I was just wondering.
Yeah, don't worry. Yeah.
Okay, thank you.
Perfect. Let me come to Sashi. Yes, Sashi?
Hey, Rishabh. That was a very good introduction. So I have a couple of doubts. So forgive me if they're very basic, very stupid.
No worries.
So like the Spark, it mainly deals with the in-memory processing, right? As you told. So what? How does it effectively deal with huge data? I mean, like we generally have some memory constraints or something like that, right?
Exactly. Yeah.
So how does that happen with Spark? That was my one question. Yeah.
No problem. You can go. You can list down your questions. That's fine.
Yeah. The other thing is compared in complex, like you have compared the Hadoop MapReduce with Spark, right? So in comparing the complexity, so MapReduce, it is a bit complex if we go on writing in Java code, and we require some Java expertise on that. So how do we compare the complexity with this MapReduce and writing the Spark jobs, or I mean, like whatever we do in the Spark thing? So how complex is that? And if you want to go ahead with Scala or Python, so which one would you suggest? So that's it.
That's it? Okay, perfect. So basically, let me come to your first question. That how basically for a big data, for a huge volume of data, in-memory computation will be helpful. Right. Now, let me tell you that for storing the data, we are definitely using HDFS, Hadoop's distributed file system. We are not touching upon that concept. Now, as far as computing this huge volume of data, what happens is, let's say each machine is having a specific RAM. So we'll be utilizing this complete RAM for caching the data, and that will be done batch by batch. So let's say you are having a block or a file. This file will be chopped into several blocks, and these blocks also might be splitted virtually. And what happens, this particular block is distributed in different partitions, and this particular block will be cached. So let's say 64 MB is the block size. Okay, and my RAM capacity is, let's say, 8 GB RAM, 3 GB RAM, 4 GB RAM, blah, 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 whatever. So basically it can accommodate, let's say, 100 blocks, or let's say 50 blocks, blah, blah, blah. So those 50 blocks, it will cache it. Yeah, and until unless the computation is not triggered, transformations will be done. Transformations means the file will be opened and filtered, and it will be kept ready. As soon as the computation is triggered, that data will be computed, the next data will be cached in, computed, cached in, computed. So basically, what was happening in MapReduce is everything was done at a time. So let's say if I'm doing any computation, it's okay, it's put into the memory, computed, put into the memory, computed, put into the memory, computed. That iterations, we have reduced it, and what we are doing it is we are completely caching the data as much as possible. Obviously, it's a constraint, or almost all the data we can't cache it, but whatever we can cache it, we compute it, we cache it, we compute it. So likewise, number of iterations or cycles are reducing. Over there, Spark is becoming helpful and it's becoming handy. It's faster over there. But otherwise, yes, as you mentioned, you can't cache in all the data for sure. And it's all about batch mode processing, so it's doing batch by batch only. Yeah, okay. That's okay. The answer for your first question. As far as complexity of the jobs are concerned for MapReduce as well as Spark, and which language will you prefer, either Python or Scala? Basically, if you ask me, my favorite language is Python, obviously, but the companies would prefer Scala for sure, no doubt about that. And companies are preferring Scala 100%, because probably I would have taken trainings in almost 25 of the banks as well as e-commerce organizations. Most of them are preferring Scala, no doubt about that. They are not using any other language. Even though Python API is available, they are not using it. And even Python is simpler, still they are not using it. So our training also, we have devised it in such a way that we'll be conducting only and only in Scala. We won't be using any other language. Yeah, we will show you how to do it in Java and Python, definitely, no doubt about that. But we'll be preferring Scala. And as far as complexity is concerned, Scala is a very smooth language. It's very easy. And if you know Java, Scala is a cakewalk. It's a cakewalk. It's very, very simple to complete. I hope that answers.
Yes, yes, pretty much. Thank you so much.
Perfect. Let me take. Let me take some question from the question box. Okay, from the question box, I'll take it later, but let me introduce somewhat more Spark stack. Yeah, and then we'll try to wrap up. Okay, so Spark SQL, as I told you, each has its own comparison with its own Hadoop stack. So Spark SQL, you can compare that with Hive. So Hive, it's a warehousing background on top of Hadoop. Yeah, so it's Spark's module for working with structured data set. Yeah, so it's not necessary. You can do your SQL. These are again abstraction layers available on Spark Stack. Yeah, so you can use SQL, Spark SQL. Yeah, to run. Like Hive was using HQL. Hive uses basically HQL Hive query language. Similarly, Spark has its own stack. Spark has Spark SQL available. Fine. Got it. So, yes. And Scala, as I told you, it clubs the advantages of both object-oriented as well as functional programming. So Scala stands for scalable language. Yeah. And you would be surprised enough, guys, that one who invented generics, those who are from Java background, they would be knowing what is generics. The one who invented generics in Java is the founder of Scala. Is the founder of Scala, Raymond. Yeah, is the founder of Scala. So that's why I would say it's very popular. The language is so named because it was designed to grow with the demands of its users. So technically, Scala is a blend of object-oriented and functional programming concepts. Got it? Yeah. Fine. So Spark's primary unit, as mentioned, it's resilient distributed data sets. Fine. So Spark's primary unit for data representation is an RDD, which allows for easy parallel operations. Other forms of data such as counters have their own representation. So as I mentioned, right, there are three things popular: RDD, actions, and transformations. Fine. So RDD stands for resilient. Why it's resilient? I told you it works on DAG, directed acyclic graphs. Yeah, and it works on lineage, lazy evaluation. So Spark RDDs can be created from any supported Hadoop source. Yeah, native collections in Scala, Java, Python can also serve as the basis for RDD. Okay, fine. So let me take some questions, guys. I would not like to go further. Yeah, we'll be starting off. Anyways, we are kicking off the batch by Monday, 8 p.m. EST. So have your VM access and materials in place, guys, from the support staff. Support staff will be providing you the VM access as well as our materials. Yeah. Okay. And here are the contact details if you miss out. And please check out your inboxes, guys, for further enrollment procedure. Let me take some questions from the question box. So there is a question from Aarti that how much Scala will be covered. Scala will be covered in depth. In depth, yeah, because you should know the Scala language. Yeah, fine. And as such, if in future what I am seeing is most of the data scientists also would be required to know Spark, because data scientists as such, what they are doing machine learning, natural language processing. Yeah, but Spark can do also the same stuff. It can do machine learning, natural language processing, graph processing, everything using Scala. Yeah, using Spark. That's what the job of data scientist is. So basically, learning Spark gives you an edge in application side as well as analytics and data science position side. Yeah. Okay. So Sam had asked the question, what certification are we working on in this training? As I told you, Sam, we'll be focusing on Cloudera as well as MapR certification to crack that certification. It's quite popular in the market as well. Fine. And you might be getting the certificate. You will be getting the certification from Techie Training Team as well. Okay. Fine, folks. So I leave it up to you guys with this. It was indeed a great questionnaire. Fine, and hope you found the session quite interesting, and at least you got some knowledge about what exactly Spark is and where exactly Spark is being standing. I mostly try to resolve the myths. You know, people sometimes have myths related to Spark. I try to fix those myths that, okay, Spark is not going to replace Hadoop, but it's computation framework. Okay? Yeah? So, see you guys on Monday and keep sparking as Diwali is approaching. Bye-bye. See ya. Cheers.